Today I'm back to share the second video in a brand new series, Getting to Know Cimatron NC. I'd like to discuss the following topics: NC setup, toolpath, target part, stock, and volume rough milling. Let's start with the NC Process Manager. This window contains all of the information for the process, like the NC setup, part and stock definitions, and the toolpath and procedures. On the left, you'll notice the NC Process Guide. It takes us through the process of creating the tool motions. It's laid out with a top-down approach. I'll skip forward to the NC setup. It contains information relevant to the subsequent toolpaths. It is used to define the preferences for the materials, machine simulation, post-processing, and part protection offsets. Next, I'll define the part. This lets the system know what should be used for the final part protection. If we had clamps, they would be defined as fixture parts and protected with an independent offset value. Moving down the process guide to stock. For this video, I'll use bounding box and add some offsets. They're split in X, Y, Z positive, and Z negative. Here are a few other options to consider. Stock may be imported from an STL file, such as a scan or an export from another system. From a mesh or group of meshes imported into the file, like the cam, lifter, and core shown here. From NURB faces, modeled or imported. Or from a 2D contour with heights defined. So I jump back to the original bounding box with some offsets. From the left, I'll create a toolpath, a 3-axis with a clearance of 2 inches. Then a new procedure, volume mill, rough spiral. Next, from the procedure wizard, I'll select the part surfaces. Then I'll select a 2-inch cutter, and I'll place it on the part for visual verification as a viable cutter. From the motion parameters, I will adjust the clearance to optimize to keep the cutter as close to the work as possible during pass connections. Working my way down through the parameters, I'll adjust the surface offset to 20 thousandths for the walls and 10 thousandths on the floors. Then the cutting mode to mixed plus climb final pass. And the vertical step type will be set to fixed plus horizontal planes. The fixed vertical step and side step values are automatically loaded from the cutter table based on the materials. The feeds and speeds are as well. I'll use the option to preview the results based on my current settings before I calculate the procedure. Let's look at the previous stock first. And now the remaining stock. We can also preview the excessive material. And we can calculate the clear length for the cutter to machine this part. In this situation, I don't need to machine to the bottom of the stock from this setup. With Cimatron, there's no reason to create a procedure and delete motions below a Z level. Just set a limit for the cut bottom and calculate. As you can see, the results are not complete. The system automatically gouge checked the holder against the stock to remove the maximum amount of material, stepping away to avoid holder collision. By creating another roughing procedure, I can choose a longer tool from the library to rough any stock too deep to reach with the previous tool. The system tracks the stock from procedure to procedure to eliminate unnecessary air machining in rough procedures. As expected, the longer, smaller cutter was able to eliminate the stock left by the previous cutter, both at the bottom and in the detail, while avoiding areas that were already machined. I've stepped back and selected a 1/2-inch cutter and recalculated the procedure. At a glance, you'll notice stretch motions in a few areas. These are created with an option called Clean Between Passes. It allows the system to use a more aggressive step over while ensuring no nubs are left behind. You'll also notice all of the motions are rounded to prolong tool life. As you can see, this machining pattern is bidirectional. It does the final pass against the part as a climb milling motion. The user can also define climb milling only, shown here with the system optimized strategy of stock spiral. The user has the ability to define basic spiral strategy as outside in or inside out with stock offset passes against the part. And as the last option in this video, the user may choose a parallel strategy, bidirectional or unidirectional, with the climb final pass against the part. Thanks for watching. I appreciate your time. Stay tuned for the next video in the series, Surface Finish Milling.